Hello everyone, welcome to AP Calculus. This is the 30 most important question series on area bounded by polar curves, and today we are going to discuss the question number 6, which is find the area inside r is equal to 3 sin theta and outside r is equal to 2 minus sin theta. So it is basically the area bounded by the two curves. So the first thing over here, the formula. When we are discussing about the formula for area bounded by the two curves, it is 1 by 2 integration from alpha to beta r1 square minus r2 square d theta. So basically this r1 is for the outside curve and this one is for the inside curve. So after plotting the graph, we can figure out whether it is which one is inside and which one is outside. So the first one is r is equal to 3 sin theta. So basically it is going to be a circle and the 3 represents the radius of the diameter of the circle, and since it is sin theta, it will open along the positive y-axis. If it was negative, then it will open along the negative y-axis. So this is the 3 over here. This is a circle for this. Second thing, we have r is equal to 2 minus sin theta. It is a type of lemma cone. Here a is equal to 2 and b is equal to 1. So a upon b over here is 2. So we can say a upon b is greater than or equal to 2 over here, either 2 or greater than 2. And since it is a negative, so it will be a circular type shape but flatten up from the top, and since it is negative, it will open along the negative. So along the, it will be a flatten up shape, somewhat flatten over here, and then a circular shape like this. This is a little bit flattened from here. So this axis over here, this is 2, this is minus 2, and 2 plus 1 is going to be 3. So 3 over here, but it is negative 3, and this is 2 minus 1 is 1. So this is 1 over here. Now we have to draw both the curves together and we have to find the area bounded by these two curves. So let's draw both of them together. So if you draw both of them together, it will look like this. One of the circle over here and another curve is this. Little flatten over here. Now this is the 3 sin theta and this is 2 minus sin theta. Now it is saying inside the 3 sin theta and outside the 2 minus sin theta. So inside the 3 sin theta and outside the 2 minus sin theta, so basically we have to find this particular region, area of this particular region. So first of all, we have to find the radial lines. Radial lines are those lines over here at which they are intersecting. So you can see they are intersecting at these 2 points. So how to calculate these 2 points? We will equate both the r values. So you can say for radial lines over here, just equate both the r values. So we can say 3 sin theta is equal to 2 minus sin theta. Take the sin theta on the left hand side. 4 sin theta is equal to 2. Sin theta is 2 upon 4, which is 1 by 2. Now you can directly see sin theta is 1 by 2. So theta is going to be pi by 6. And in the second quadrant, it will be 5 pi by 6. And we can directly see from the graph that one of the radial line in the first quadrant, which is this pi by 6, and second one is in the second quadrant. This angle, this region is 5 pi by 6. So we have to go from smaller to greater. So pi by 6 to 5 pi by 6 we will go. And now this is the alpha over here. Basically alpha is pi by 6 and beta is 5 pi by 6. Now outside curve is this white color one from the origin. If you see, the outside one is this white color one. So 3 sin theta is outside and 2 minus sin theta is inside curve. This is inside and that is outside. So we will do outside minus inside. So therefore the area will be 1 by 2 integration from pi by 6 to 5 pi by 6, and outside curve is 3 sin theta. So 3 sin theta whole square minus 2 minus sin theta whole square and integration of this. Now either you can substitute directly this in the calculator and you can get the answer, but suppose if you want to do this without calculator, which we can do, so let's do it without the calculator. You can substitute this expression in the calculator also and you will get the direct answer. So this is 1 by 2 integration pi by 6 to 5 pi by 6. Let's open this parenthesis first over here. It will be 9 sin square theta, and when you are going to open this, it will be a square plus b square minus 2ab, but due to the minus it will become negative. So a square and b square minus 2ab will become plus 2ab, so it will be 4 sin theta will be positive. Now this is going to be 9 sin square theta minus 1 sin square theta, that is going to be 8 sin square theta over here, and 8 sin square theta minus 4 plus 4 sin theta. So this sin square theta we can change it as 1 minus cos 2 theta by 2. In many previous videos we have learned this formulas. Minus 4 plus 4 sin theta, and this is the integration with the 1 by 2, integration with the 1 by 2, it's going on. Now this 2 will cancel this 8 4 times, so finally we will be having 4 minus 4 cosine of 2 theta minus 4 plus 4 sin theta d theta. So here you can see this 4 and 4 will also get cancelled out. So basically we are left with 4 sin theta minus 4 cosine 2 theta. Pi by 6 to 5 pi by 6. 4 sin theta minus 4 cosine 2 theta. So 4 sin theta minus 4 cosine 2 theta. Now we can integrate this thing. Integration this will be minus 4 cosine theta. The integration of cosine 2 theta is sin 2 theta over 2. Divide by 2, and this is going from pi by 6 to 5 pi by 6. We can take this minus 4 outside also. So when we take this minus 4 outside, that will become minus 4 by 2, and we'll be left with cos theta plus 1 by 2 sin 2 theta, pi by 6 to 5 pi by 6. Now let's substitute the values over here. So if you put the upper value, cosine of 5 pi by 6, cosine of 5 pi by 6 is pi plus pi by 6, which is minus root 3 over 2. Then if you put the 5 pi by 6 over here, so that will become 5 pi by 3 actually. Sine of 5 pi by 3, sine of 5 pi by 3, that is also going to be negative root 3 by 2. So negative root 3 by 2, so it will become 1 by 2 times negative root 3 by 2. This is the upper limit, minus. Now lower limit, if you put the cosine of pi by 6, cosine of pi by 6 is root 3 over 2, and when you put the pi by 6 over here, that will become sine of pi by 3, which is also root 3 over 2. Now let's simplify this thing. This is minus 2, so minus root 3 by 2, this will become minus root 3 by 4, this will become minus root 3 by 2, and this will be minus root 3 by 4. So finally, if you are going to solve this thing, if you distribute the 2 inside, minus 2 if you distribute the inside, or let's solve this part over here, minus 2 is outside, minus root 3 by 2, minus root 3 by 2, that will be minus root 3, and minus root 3 by 4 and minus root 3 by 4, that will become minus root 3 by 2. So now if you distribute the minus 2 inside, that will be 2 square root of 3, and this will also get cancelled, it will be square root of 3. So finally it is going to be 3 square root of 3. So 3 square root of 3 square units, that is going to be the final answer, or in decimal, if from the calculator if you calculate, that is going to be 5.196 square units. This is the final area bounded by these two curves. So I hope you have understood this calculation. So main part is you can use the calculator also if it is allowed, otherwise you can do like this. So I hope you have understood this calculation. So if you have any other doubt related to this, you can send your doubt over this particular mail ID. Thank you for watching.